linear and rational equations. Linear and rational equations. Okay, on page 120, if you have it, if you have your computer, that's fine too. I would like to start with just a simple equation like number 10. 10 on page 120. 2 quantity x minus 1 plus 3. Feel free to choose. If you have your books, if you have your computers, if you'd like to choose, I'd be more than happy to solve a problem of your choice at any point in time. As long as we keep up with the schedule, I'm fine with any problem you want to choose at any point in time. Every time we're given, and I'm going to say this now for the entire semester, and I will apologize. I know this is only the second class, and I already started apologizing. Yes. Here's why. I will sound like a broken record. I will repeat and repeat and repeat. And I have to say that I think it's the only way. So I apologize again for my accent, and if you can get used to it, I'm happy. If you want to help me pronounce better, I'll be more than happy to learn from you. So the first question is, every time I'm given an equation to solve, is what type is it? If I'm able to identify it correctly, I have great chances of being able to solve it correctly. If I don't even know what it is, how will I be able to start even, right? So what type is it? What type of equation is it? It is a linear equation. What does a linear equation mean? A linear equation, first of all, requires that the variable has power 1. Only power 1, not power 2, 3, or 1 over x. If we have a product of two variables, you can say this is linear, right? Power 1, no. It's not linear if it has two variables and they are multiplied. What about 1 over 2x? This is not linear. You can say, but there is power 1. No, it's not. 1 over 2x is 1 over 2 times x to negative 1. So let me refresh your memory. X raised to negative n is the same with, other than Mallory, anyone else? We will have to ban her. No, I'm kidding. I'm kidding. I'm trying to be funny. I'm not successful very often. So 1 over x to the nth power. So please make a note, refresh your memory. And here's another kind request that I have for you. And I did not mention it. And I will, moving forward, I'm kindly asking you to do this. Get a little notebook. I don't have a little notebook with me, but I'm just going to say, okay, a little notebook. In that little notebook, you should have it handy at all times when you do math. When you're in class, or you're at home, on the computer, in the math lab, it doesn't matter. And always in that notebook, put the date on. For example, I would have started January the 23rd, and I would have said these 3 special products. She's going to kill me if I don't remember those. No, that part you don't have to write. Just put those 3 in there. Today, 1/28. I refresh my memory on negative exponents. Negative exponents mean a fraction. X to negative 5 means 1 over x to the 5th. And I will have this handy all the time and put in there every piece of information that I didn't remember or that I hear her saying all the time, and this is important, and this is important, and this is important. And I would write it in on my notebook. And every time I come to class, I would read those notes, and they will get embedded in my brain. I guarantee you. So, but I will have this handy at all times in my pocket. I'll go to the bathroom for 10 minutes and because it's the only way. It's the only way. And then everything will click. You'll see. Trust me. Okay. So this Although it appears that has power 1, it's not power 1. It's power -1 because of this rule. X to -3 is 1 over x to the third. So indeed, this is a linear equation. Okay, what is the first step?
So you said there's no exponents in a linear equation? Yeah.
Exponent 1.
Okay, just the first part of it.
It's a first power, correct. So what do I, yeah, I have to distribute. I have to remove these parentheses first. So when I distribute 2 to x minus 1, I get, perfect, plus 3 equals?
X minus 3x minus 1.
So when we distribute to one term, we have to distribute to all. Are you with me? Thank you, Tony. Are you with me?
No.
Which part?
Can you just go all the way up like that?
2 times x,
Yeah.
2 times -1. I copy 3, x minus 3 times x minus 3 times 1.
Okay.
Are you with me, everyone? Yes? Perfect. Now we have to combine like terms. Do not try anything before we combine like terms. The left-hand side is 2x, and then? Perfect. The right-hand side is?
-2x minus 3.
Very good. I prefer, it doesn't matter what you want to do. I'm fine with whatever you decide. That's what I meant to say. But I prefer the variable on the left-hand side most of the time. So I want this term to be moved here, and I want this term to be moved here, to the other side. So the linear equation requires the terms to be separated. The terms with x go on to one side and terms without x to the other. This is typical for linear equations. We're not going to use this in other situations. So separating like that, okay? So when I move one term from one side to the other, the only thing that changes is the sign. So when I move this term, which is -2x, to the other side, it becomes +2x, and I have to add it to 2x. What do I get? 4. Excellent. When I move this term, which is 1, to the other side, it was positive on 1. It goes to the other side, it's negative. I have -3 minus 1. At this point, and only now, I do what? I divide both sides by 4. The left-hand side is 1x, that's what I wanted, and the right-hand side is?
-1.
And this is the final solution. Unless you say to me, I need another linear equation, I would like to move on. But which means that all linear equations should be done between now and Wednesday. So we can say, I know linear equations, and I'm done with the special products. Yes?
I understood it. I'm just wondering, when you're talking about the negative exponents, how it's
No, I was just saying that 1 over x is not a linear equation. If in an equation I have 1 over x, that's no longer linear. The whole equation changes into something else. That was the only point I was making. So now in my notebook about what I just saw, I would write down, when I solve linear equations, eventually I have to separate the terms with x from the terms without x, and at the end I divide or multiply, whatever needs to be done. This is typical for linear equations. No other equation would use this method. Just linear equations, in which I separate the terms, combine like terms, and then eventually divide. No other equation uses this step. I will write it down for linear equations. Okay? Anyone else needs a linear equation, or can we move on to rational?
Oh, you can use that one.
Sure. So let's take a look at 26 on the same page, 120. And we have x plus 1 divided by 4 equals 1 over x plus 2 minus x divided by 3. Again, I'm asking myself the same question. What type of equation is it? And this time I see fractions in there. However, there is no x in the denominator. If there is no x in the denominator, this must be linear. And x at the top has power 1. Do not correct anything. So if I have this situation, this is no longer a linear equation because it has x squared. There is no x in the denominator, and all variables, in this case x, have power 1. Therefore, this is indeed a linear equation. Every time I'm given something like this, I will always remember two keywords. I didn't say that. So I did say the keywords. What were the keywords? Always. Forever. Whenever you do math of any type, what are the two keywords?
Of any type of math?
Any type of math. Two keywords.
Problem solving?
No, but this, probably I didn't see. I didn't not see. I didn't say. Did I say that? See how simple, how easy it is for me to go back and see? Okay, let me see if I said that.
I don't remember.
I did not. Okay, so two key words that I will also put in my notebook. I'm going to ask you about these two keywords forever. Here they are. Factor, simplify. I did not say them. So every problem you will give me to solve, if it's an equation, if it's an inequality, if it's a word problem, a system, whatever it is, these two will always be in the back of my mind. Of course, there is nothing to factor here. It's not a factoring situation. Some situations will work very well with both keywords. Some with one, but definitely one or the other will be implied somehow, definitely. So if it's not factor, because this is not a factoring situation, obviously it's a simplification situation. I look at this equation and I'll say, no way, I'm not going to work with fractions. I refuse. So in order to eliminate those fractions, what do I have to do?
Multiply.
So then I'm trying to simplify. How do I simplify?
Lowest common denominator.
Exactly, the least common denominator. Very good. Can anyone give us the least common denominator? Very good, awesome.
Can't you find that in the calculator?
You can, but I'm hoping that,
No, we don't.
yes. Okay, here is what I recommend you should write. Of course, I accept other methods. But since I'm multiplying fractions, I'll multiply by 12 over 1, I'll multiply by 12 over 1, and I'll multiply by 12 over 1. So always simplify before you multiply. Always simplify before you multiply. In other words, I will simplify 4 and 12. What do I get? 3. So it's 3, quantity, x plus 1, equals. Please simplify here, what do we get? Plus. Please simplify here, what do we get?
4.
Very good. So please keep in mind, factor, simplify, factor, simplify. This is not a factoring situation, so this is a simplification. Now we're back to the previous problem. So this problem had one additional step in which we eliminated fractions. That's the only difference. So like before, I will distribute 3x plus 3 to 8 minus 4x. Do not move terms around before you fully simplify. So fully simplified means 3x plus 3 equals 10 minus 4x. If you prefer keeping the variable like I do on the left-hand side, then you will move this and you will move this. So please tell me what you do, what you have at this point. On the left-hand side, yes, we have 7x. I completely agree. And on the other side, careful.
Oh, you
7.
moved that.
Yes. So I move 3, which is positive, to the other side becomes negative, and 10 minus 3 is 7.
Why don't you just write it the other way? Why don't you just put the arrow? She's showing that.
I'm showing that I'm moving this to the other side. You write it the way you're comfortable with.
Okay.
But I would like to move forward. I'm not saying that you should memorize anything. I'm not saying that you should cut back on writing. I'm just saying, please cut back on writing if you can. Okay, so 7x equals 7, therefore x equals 1. So we accomplished so far 2 different things. We know 3 special products, and we know how to solve any linear equation. Are you in agreement with that? And we're going to practice between now and Wednesday, correct? Okay, good. So now let's move on. I'm looking at the time because I want to split my video in half. Okay, I'm fine. Only because of, it takes a long time to upload. Okay, ready? So here's the next problem.
We're on the same page, right?
We are on the same page, yes. Okay. 47 on page 120. 2 over x plus 1 minus 1 over x minus 1 equals 2x over x squared minus 1. So don't forget to, I want to remind you to write those important topics, important information in your tiny notebook. Okay? So what will you write about linear equations? They have to have the variable to the first power. They cannot have products of variables, and variables cannot be in the denominator. Okay? So what type of equation is this? And let me ask you the following question. Is this linear?
No.
Of course not. A linear equation cannot have x in the denominator. So then what can it be? Yes, it is rational because it has fractions and it has x in the denominator. Rational. This is indeed a rational equation. So please remember that. I will write it down in my notebook. A rational equation has to have x in the denominator. Otherwise, it's not rational. Okay.
So if any time if it has an x in the denominator, it's always right.
Very good question. No, it can be a combination. For example, I can have the square root over x minus 1 equals 5.
Okay.
So that is a more sophisticated type of equation. It is rational, but it's combined with a radical equation. So if there are only fractions like this and there is no absolute value, rational or radical expression or a log expression, this type, just fractions, nothing sophisticated, and x in the denominator, then it will always be rational. Okay, I'm going to show you the method that I think is the easiest in most cases. You do not have to adopt it if you don't like it. You can use your own. If you know a different method that you are comfortable with, please use yours. Here is what I recommend as step 1. I will move this term to the other side. 2 over x plus 1 minus 1 over x minus 1 minus 2x. Of course, like before, we have to change the sign. And before I continue, I would like you to tell me, what is this? No, the x squared minus 1. Right, we discussed it last time. How do I factor it?
X plus 1, x minus 1.
Excellent, Tony, thank you. X plus 1, x minus 1, equal symbol. Each equation has to have the left-hand side, has to have the equal symbol, and has to have the right-hand side. So what is left on the right-hand side? Of course, if you omit to write the equal symbol and the right-hand side, which in this case is 0, then you are changing the equation to an expression. You cannot simplify to the sides. This is a rational equation. So, or any equation, you cannot simplify to the sides. Just remember, look at what we wrote before. Left-hand side, equal symbol, right-hand side. 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 So trying to simplify and continue with another equal symbol here brings 0.
So if you ever have 2 equal signs, the second equal sign is going to be 0?
No. Points 0 on a test or final exam.
Oh, you got 2. All right.
0. No equation can have more than one equal symbol. If you continue to the side, you'll lose track of which one is the left-hand side, which one is the right-hand side, and you will never solve. So notice one more time, each equation is on one row, and it does not have more than one equal symbol. You may want to put that down in your notebook.
Can you say that again?
Yes. Which part?
Um,
Each equation has a left equal and a right, nothing else. You cannot have two equal symbols, you cannot simplify to the sides. So then, here's my left-hand side, here's my equal symbol, here's my right-hand side. On the left-hand side, I see expressions with denominators, and I have to write restrictions on the variable x. What does that mean?
You can't have x equals, like you can't have the denominator be 0 and
Correct.
have it be a rational.
Why we're not allowed to have 0 in the denominator? Correct. So here's another note for you. 10 divided by 0 is undefined. This is a fancy word. What does it really mean? It does not exist.
There's no 10 out of 0.
Yes,
You can't pull 10 out of 0.
it does not exist, but we like to say undefined. So therefore, x plus 1 cannot be 0. X minus 1, oops, cannot be 0. Which means that x, in conclusion, x cannot be,
Negative 1 and 1.
very good.
Because it means
Remember, these are linear equations. We just refreshed our memory on how to solve linear equations. When I solve for x, I have to move 1 to the other side. When I solve for x, I have to move negative 1 to the other side. Right? So that's how we get that x cannot be plus or minus 1. Agreed? If x is either 1 or negative 1, what will happen here? Either 1 or 2 of those fractions will be undefined. If x is 1, these two will be undefined. If x is negative 1, these two will be undefined. Are you with me?
No.
What is the problem?
I just don't know how you do it. If you set
So the denominator x plus 1 cannot be 0.
right.
We just solved the linear equation a few minutes ago. I move 1 to the other side.
Okay.
So x cannot be negative 1.
Right. Got it.
X minus 1, I move negative 1 to the other side. X cannot be 1. And that's how we get this.
So you just put plus or minus 1 because it can't be
This cannot be negative 1. This cannot be 1.
1. Okay.
When I move positive 1 to the other side, it becomes negative. So x cannot be negative 1 and x can, you see that these two are different, right?
Right.
So one has,
A negative 1.
right. Any questions over there? Okay. Good. So now, next step, I want the least common denominator. Notice what I did. I drew a long fraction line, I copied the equal symbol, and I copied 0. Now I'm looking for the least common denominator. What is the least common denominator in this case?
X minus 1. For the first one?
We are talking about 3 fractions.
Yeah. You want the answer for,
I want the least common denominator for this.
x plus 1 is minus 1.
Of course, there are 2 different factors. Both factors have to be in the least common denominator. If I have 5 different factors, all 5 factors have to be in the least common denominator. So there are 2 different factors, and they are x plus 1 and x minus 1. Very good. Perfect. Okay. I want to stop here for a moment. I'll come back in a minute and a half. Here's a question for you. If I have 1/2 minus 1/3, what is the least common denominator? Indeed, do you agree? 2 and 3 have nothing in common, so then the product must be 6, right? So now what is the next question I ask myself? Because if I copy 1 minus 1, that's 0, right? It's nothing. It means that I have no knowledge of algebra at all, or arithmetic for that matter. 2 was multiplied by?
3.
I multiply the top by 3. if I choose to multiply the denominator by 3 to get 6, I have to do the same thing to the top. Do you agree?
Yes.
3 was multiplied by what to get 6? I have to multiply the numerator by the same thing. So how much is 3 times 1? Minus, how much is 2 times 1? And how much is, you cannot simplify in a sum. Be very careful. You don't attempt to simplify 2 and with 6 or 3 with 6. Let me write a note. We simplify. I know we can be tempted. We simplify only factors, comma, never terms. These two are terms. We never simplify terms. This is another note for your notebook, in case you agree to do that. So 3 minus 2 is the exact same method we are going to apply with in our equation, rational equation. Ready? So then, x plus 1 was multiplied by what to get this? Correct. So then the numerator has to be multiplied by the same quantity. X minus 1 was multiplied by? Awesome. The numerator has to be multiplied by the same quantity. Finally, x plus 1, x minus 1 was multiplied by?
Nothing.
Nothing, or when you say nothing, you mean 1, you don't have to write it. I just wrote it this time. So now, can anyone tell us slowly what should the numerator be now of this fraction? Very good. 2x minus 2. You cannot pick and choose. You cannot pick and choose. If you distribute negative 1 to x, you have to distribute it to 1 as well.
Oh, so minus x minus
Very good. And now?
minus.
Excellent. Let's stop for a moment and try to digest this for a second. We'll have another example in a minute, but is it clear? As the next step, we must combine like terms. Negative x minus 3.
2x, shouldn't that be equal to? Yeah, minus.
You have 2 apples and you give them to me.
I thought that was an equal.
The equal is here.
Minus.
That's where the equal symbol is. We haven't gotten to it yet. Better?
Mm-hmm.
So then I have negative x and minus 3. Do you agree so far? Good. So the right-hand side, do not write it just yet. I have a question for you before we write it. Would you allow me to write that 10 is the same with 10 over 1?
Yeah.
Would you allow me to say that negative 7 over 1 is the same thing with negative 7?
Yeah.
Will you allow me to say that x is the same with x over 1?
Yeah.
Finally, 0 over 1.
Yeah.
Awesome. So instead of writing 0, I wrote 0 over 1. Can anyone tell us why? What am I getting at? What am I trying to show? I'm sorry? This was moved to the other side. There was nothing left at on the right-hand side. So it was 0 all the time. Okay. Yes?
Now, the negative x minus 3, where did that come from? I'm sorry, did you factor off the top?
I'm not factoring. I'm combining like terms, right?
Okay.
So negative 2 with negative 1 is negative 3, and minus x is minus x. But I have to put it in descending order.
Okay, so you have to put negative x in this?
But it is negative x. I can't.
Minus x, okay.
I have to copy what I have. I can make any changes. Yes, Tony?
I got a question.
Yes.
The problem after the 1 over x minus 1 is equals 2x over x squared minus 1.
Correct.
Now, why would you move the 2x over x squared minus 1 all the way on the
I
other
can
side?
do whatever I want. And when I move a term from one side to the other, as long as I change its sign, I'm fine.
But if you just multiply all three terms by x plus 1 and x minus 1,
Awesome. It's a perfect method. I don't use it though.
that's where you confuse
And I'll
me.
show you. And I'll show
That's
you
where
why.
confuse me.
And I'll show. But you don't have to use my method.
Okay.
And I'll show you why I'm not using that method. And I'll show you in a moment why I don't use it. It's a very good question. But if you're comfortable,
That 0 was losing me when you equal 0.
allow me to answer. Your colleague was asking you a question. So I'll show you why I don't use it. But I said from the beginning, I'm going to show you a method. If you're comfortable with yours, close your eyes. If you're happy with what you know, which makes me very happy, don't even look. Okay. So let's finish it, and then I'll go back and explain why I'm not using that method. So are you comfortable so far? Say it again.
How did it equal 0?
I'm sorry?
How did the top equal 0?
Okay. From the very beginning, we moved this term to the other side, and we had 0 on the right-hand side. So there is nothing. I have 0.
Yeah.
So I just have to copy the 0. I only copied it from here.
Okay.
Instead of writing 0, I wrote 0 over 1.
So we're not done?
We are not done. Of course not.
Okay.
Of course not. Okay, other questions? Go ahead.
Just you go ahead. I'm just going to go ahead. Go ahead, you go ahead.
No, but I'd rather answer your question.
No, I mean, the only question that I had
Yes.
was when, I don't know if I'm taking you all back, but when you got x plus 1, x minus 1, and when you said to move the last equation to 2x and then x2 minus 1, you said to move it over. But aren't all we're doing is bringing the x plus 1 and x minus 1 down to the new, just keeping it on the numerator?
You mean the x plus 1, x minus 1? They are
Yes.
they are in the denominator.
Right, I mean, not the denominator. So we're just keeping that in the,
Yes, you cannot eliminate that.
right, so, okay, I think I got it, okay.
Right. The first time we work through a problem, I don't expect everyone to be able to understand each and every step. But the second time you're going to see it repeated, and the third time you should have no difficulties.
Okay, okay.
It's a method that I think it's better than what you know,
I learned this.
but you don't have to switch to my method. Remember I said that before I started. If you're comfortable with your method, this is valid throughout the entire semester. If you're comfortable with something, no need to change. What I would like you to do is compare the methods. If my method looks better, use it. If your method looks better, forget about mine. That's not a personal thing at all. I'm used to certain things, you're used to other things. If whatever works, don't reinvent the wheel. Okay, good. So far so good?
Yeah.
Yes.
Are we allowed to use our notes on quizzes?
No. Oh, you mean on quizzes at home?
Yeah.
Yes, of course.
Okay, so in class quizzes, you can't have our notes.
We don't have class quizzes.
Just their tests. Quizzes are online.
Yes, tests.
So all of them are online?
If-
We'll take those tests?
Yes, no, we're going to have only tests, because if we take time from quizzes, then you're going to have to do a lot of more work at home than I can do in class. I
Right,
won't
so
be
we
able
take the tests in class?
Yes, on
Okay.
paper, yes.
Quizzes.
At
And
home.
on tests, you can't use your notes, but on quizzes. you can.
Correct, correct. It's on the syllabus. We can go back and revisit that if other questions. Yes. So let's finish it up. Why do you think I put over 1 instead of just writing just 0? Why did I write 0 over 1?
Put it in a fraction.
Perfect. Why did I choose excellent? That's the correct answer. But why did I do that?
So you can
What
multiply
does this remind you of?
This is, no,
The left-hand side is a fraction, which is a over b. The right-hand side is a fraction, which is exactly. That's exactly it. Only in a proportion.
I was too happy to delete the denominator, so I didn't think it could be right.
So in a proportion, we can cross multiply. So if I get to this stage in any situation, then AD must equal BC. Any questions so far? Are we okay? Yes? I would like Brenda and Alexis to stop talking when I talk. Is that okay? Thank you. So then let's go ahead. Cross multiply and tell me what you get. When I multiply this by this, what do I get?
Negative x3.
Very good. When I multiply this by this, what do I get? So do not ask, you can, but I recommend don't ask where the denominator go. It didn't go anywhere, right? I just cross multiplied. I'm allowed to. A over B equals C over D. It means that AD equals BC. So that's how we got this. What type of equation is this?
A linear.
Exactly. What do I do? Good. Final answer.
Negative 3.
My first concern. Where is my first concern? What is my first concern? Here's my first concern. Is it 1 or negative 1?
No.
No. So then I will say yes.
Wait, what was your first answer?
If it was a
Restrictions. The restrictions we wrote. Right here. Right? That's my first concern.
Okay.
Okay, let me just explain one thing concerning multiplying both sides by blah, 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 blah. Okay, so if I have a situation like this, do not write this. We're not going to solve this equation. We are not going to solve this. I'm even going to remove it from the before I scan this. Tony said, and he's right, why don't you just multiply both sides by how many factors? What will be the least common denominator now?
You have to multiply by
How many factors? 4 different factors. First of all, I will not even know how to write it, right? So it's going to be much bigger than what I have here, right? So I'm going to have to multiply this by x plus 4, 3x plus 2, and 2x minus 1. I cannot even, it doesn't even fit. Then I multiply this by the other 3, and I multiply this by the other 2. And then I start simplifying and crossing out. So this eventually may get more confusing. But I have to agree with the difficulty level that we are using. Both methods work just fine. It doesn't matter. Okay? But that's one of the reasons why I don't use this method. Here's another reason why I don't use, I use the expressions at the top. Is because at this stage, if a student writes 2x minus 1 minus x plus 1 minus 2x over x plus 1, x minus 1, it will be too tempting not to happen. What? What could happen here? Someone will simplify this. But that's not allowed. Because I just wrote a note. You cannot simplify terms. This is a term. And you're simplifying it with a factor. So I'm trying to avoid this. And I'm trying to avoid this mess. However, I'm very happy if you use the method you like. Always, at any point in time. So any questions for me before we choose another rational equation? Yes. Yes, of course. You don't have to say it. I will always ask you if you need more examples. Always. Always. My concern is for you to understand and be able to follow. Okay, let's look at 44. You can choose if you'd like at any point in time. I'll tell you where to pick from, and you can pick any problem.
You're still on page 100.
Yes. Yes. Still on that. I will write it right now so I don't forget. 2x plus 3. No, it's 2x plus 6. Sorry. And then plus 1 over x minus 2. In case you agree with my method, you do not have to. But in case you agree with my method, you will write this. 3 over x plus 3 minus 5 over. How do I factor 2x plus 6? Is there a way of factoring 2x plus 6?
X plus 2, X plus 3.
It's not a squared term. It's
Pulling
not.
out the 2, so it'd be
Perfect.
2 parentheses x plus 3.
Very good. Minus 1 over x minus 2 equals?
Which is 0.
How many equal symbols does an equation have?
1.
Perfect. Awesome. What would you give me next?
Negative 3. And 2.
Do you all agree with the given restrictions? Everyone? Denominators cannot be 0. X plus 3 cannot be 0, which means x cannot be negative 3. X minus 2 cannot be 0, which means x cannot equal 2. Is that okay, everyone?
So you want us to write these restrictions like?
Mandatory. Mandatory, yes. When solving rational equations, you can put it in your notebook. When solving rational equations, I must state restrictions. It's a must. Yes.
Can you explain how you got the restrictions again?
X plus 3 cannot equal 0. X cannot equal negative 3. Linear equations. I'm not changing the sign. I'm moving one term to the other side, which technically changes the sign. Right? Are you with me, everyone? Yes? Linear equations. We have to put that aside and, have it under our belts. Good. So you gave me 2 restrictions. We all agree with them? Then I need the least common denominator. How many factors do we see in the denominator? If you say 15, you have to give me 15. If you say 10, you have to give me 10. How many factors, different factors you see in the denominator? One more time. 3 different factors, and they are? And they are?
X plus 3.
And we don't start with that. We start with?
2.
Very good. Very good. Three different factors, 3 different denominators. Awesome. 3 different factors, all 3 in the least common denominator. Very good. Adjustments for each fraction, please. What will you say about the top of the first fraction?
2 parentheses x minus 2.
Correct. But I'm going to write it to x minus 4 for convenience.
Okay, why are you writing 2? Why are you writing 4? 2x minus 4?
So x plus 3 was multiplied by these 2. 2 times x is 2x. 2 times negative 2 is negative 4.
Okay.
What about this one?
X minus 2.
Do you all agree with x minus 2? Is that a yes?
How did you get the x minus?
This is this. This is the additional one. So the denominator was multiplied by x minus 2. The numerator has to be multiplied by the same quantity. Mandatory. Better? Good. And now x minus 2 was multiplied by 2x plus 6. Do you agree so far?
Yeah.
Any questions before we continue? Any questions before we continue? It needs a lot of practice. This is not a trivial type of equation. I would not say that everyone knows how to solve a rational equation. It's not an easy equation. I have to say that. Good. So then, can anyone give us the top?
6x minus 12.
Awesome. Do you all see 6x minus 12?
Plus 10.
Plus 10. Very good. Minus 5x and plus 10. And then?
2x minus 6.
Very good. Minus 2x minus 6. Awesome. Great job. Do you all see this?
No,
Which one?
none of it. You going too fast, honestly.
Yeah, you are going too fast.
The problem that I was still on, you skipped off of it when you were talking about when I was asking you to multiply the denominator as all three terms. I
We're
came
not-
up with a whole different answer, so I wanted you to stay on that one and switch. So I didn't want to hold you up.
So, do you understand what I did?
I'm not even paying attention to that one because I'm still on my mind. So when
Well,
I'm
work on it as you like, and we at the end of the class we can work on it together again. Let's do that. Okay. Other questions? Okay. So let's combine like terms. 6x minus 5x. X minus 2x. Very good. Negative 12 plus 10. Negative 2 minus 6. Very good. What do I do next?
0 over 1.
Awesome. To remind me of what?
If it's a fraction, you can cross multiply.
It's a proportion. Only in a proportion we can cross multiply. Let's cross multiply. What will you write?
Negative x. Yes, negative 8.
Equals 0.
Which means negative x equals 8, or x equals negative. Very good. Awesome. Okay. Do you think we need another, or can we